Okay, next we have some problems dealing with the ideal gas law. Now, with all these problems, it's best to pause the video, try the questions out yourself one at a time, see if you can get them right, and then go back and check the video to see if you've done them right. That will help your knowledge of chemistry grow. Now, before we do this, let's just talk in general about the ideal gas law. Here's the formula. PV equals nRT. Sometimes hear people just call it PIV-NERT. This stands for the pressure. This stands for the volume. This stands for moles. This stands for temperature. And this one right here, this is the gas constant. And it's interesting because with this gas constant, it is a value that we plug in. And here it is, 0.0821 atmospheres times liters over moles Kelvin. Oh, good grief. So atmospheres times liters over top of moles times Kelvin. That's a ridiculous unit. And this little number is a little secret. We plug this into these problems and we get the answers right. There's a lot of science behind why it works, but for now, we just need to know that number. And you need to know that it contains these units. Now, since it contains these units, this number only works if the pressure of this problem is in an atmosphere, if the volume of whatever you're looking at is in liters, if the moles are in moles, and if the temperature is in kelvins. Now, you're already used to converting everything into kelvins when you're dealing with gas, but you have not had to turn these other ones into these things. So just be aware of that. So now let's look at the problems. I'm going to write the formula up at the top of the assignment. So PV equals nRT. And I'm also going to just remind myself that R equals 0.0821 atmospheres times liters over moles times Kelvin. You'll get tired of writing that, but it's a good habit to do. So looking at this first problem, and you'll notice when you're dealing with gas laws, we were dealing with Boyle's, Charles, combined. Those we're looking at before and after. This is not a before and after situation. We're not saying, oh, this is how it was before, this is how it is after. No, not at all. This is talking about a gas right now. Right now, I've got 4 moles of gas. It's at this pressure. It's at this volume. What's the temperature? I'm not changing anything. Everything is staying stable. So I'm going to go ahead and put the numbers in the right spots. So I need to think about, first I'm going to put the pressure. That's 5.6 atm. The volume, that's 12 liters. Now I know I can flip-flop these. 12 times 5.6 or 5.6 times 12, that's the same thing, but it's good and it's wise to try to put these in the same order. It will help you out. Next, moles, okay. 4.0 moles. Next, I just get to plug that number in, 0.0821 atmospheres, liters over mole Kelvin times temperature. So now that I have that all set in there, I've got to do algebra, every high schooler's favorite thing to do. I'm going to go ahead and put divide and divide. I'm going to put 4.0 moles on this side. I'm going to put, oh boy, 0.0821 atmospheres, liters over mole Kelvin. I'm going to do the same thing over here. 4.0 moles. I'm going to do 0.0821 atmospheres, liters, moles, Kelvin, parentheses. Whew. Now we can see on this side, cancel, 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 cancel. Okay. Now I can go over to this side. Again, order of operations can screw things up. So what I personally do, I take 5.6 times 12 equals divided by 4 equals divided by 0.0821. Sometimes what people will do is they'll just figure out this part of the problem right here. Figure out this part of the problem right here and divide the two numbers. Now when I do all that work, I'm going to end up getting 204.628. And again, remember, using this big old unit here, we know the answer for temperature is going to be in Kelvin. Now with units, there's only 2 sig figs, 2 sig figs, 2 sig figs. So I'm going to get number 200, put a line right there for Kelvin. Or some people might do 2.0 times 10 to the second Kelvin. That's fine also. Next, I've got an unknown quantity of gas. I've got the pressure, I've got the liters, I've got the temperature. How many moles of gas do I have? So let's go ahead and do P first. I'm going to write 1.2 atm. The volume, let's do 31 liters, equals the moles. Well, that's what we don't know, N. The R, 0.0821 atmospheres times liters over moles Kelvin. Times, what's the temperature? Well, it's 87. Remember, since this uses atmospheres, liters, moles, kelvins, all the other units have to be those. So instead of just writing 87, I've got to add that to 273, and I get 360 Kelvin. Okay. Now that I have this, I need to get the N by itself. So using my skills of algebra, I'm going to hold off on the unit for now. 0.0821 and 360. Okay. 0.0821 and 360. Okay. Cancel, 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 cancel. Okay, I'm going to go ahead and take this set of work. Take 1.2 times 31 liters divided by these two at the bottom. When I go through and do that, I get an answer of 1.3 moles. And, oh, well, actually, I got one. In your calculator, you probably saw this, 1.2586. But with sig figs, once I convert that over, 2 sig figs, 2 sig figs, 2 sig figs, it's going to be 1.3 moles. Next one. If I contain 3 moles of a gas in a container with a volume of 60 liters and a temperature of 400 Kelvin, what is the pressure inside the container? So I don't know pressure this time, but I do know the volume. That's 60 liters. That'll be important with sig figs. Equals the N, that's 3.0 moles. The R, that's 0.0821 atmospheres, liters, moles, Kelvin. Okay, good. Times the temperature, 400 Kelvin. Add two, no, don't add 273. It's already Kelvin. That's one people will goof up on. Okay, now I've got to solve for the P. So I divide both sides by 60 liters. Now, I know that I'm solving for pressure, so I know my answer is going to be in atmospheres, but let's just look at this for a second. Moles cancels out with moles. Kelvin cancels out with Kelvin. This liter cancels out this liter. So yeah, that's why my answer is going to be an atmosphere. So I take 3 times 0.0821 times 400, and then I divide that by 60. So for this one, I'm going to get an answer of 1.642 with sig figs. I'm going to change that to 1.6 ATM. Okay. Next, number 4. I've got 7.7 moles of gas. I've got the pressure. I've got the temperature. What's the see? Remember, we're not looking at any before and after. It's looking at a gas right now. So I'm going to go ahead and put 0.090 ATM on the spot where P would go. For V, well, I don't know. That's why I'm going to put V. It's not V1 or V2. It's just V. Right now, what's the volume? The N, that is 7.7 moles. The R, 0.0821 atmospheres, liters, moles, Kelvin. And then temperatures, 56. That's Celsius, so I better add 273 to it. So I'm going to go ahead and get 329 Kelvin. Boom. Now I'm going to divide both sides by 0.090 ATM. Divide this side by 0.090 ATM. Cancel, cancel. And I know my volume is going to equal, well, I've got to cancel and cancel, cancel and cancel, cancel and cancel. I'm going to get just liters for my answer. I do all the math on this, and I'm going to get 2310. Well, with sig figs, it's just going to stay with 2 sig figs, so 2,300 liters. We know it's liters because that's the leftover unit that wasn't canceled out. Next. Oh boy, I've got 17 moles of a gas at a temperature of 67, a volume of 88.89 liters. What is the pressure? So I don't know P, but I do know the V. It's 88.89 liters. I don't know the, well, I do know the moles, 17 moles. I do know 0.0821, my secret little number I get to, not secret, it's well known. My decoder number, plug that in there. I go ahead and figure out the temperature. It's 67 plus 273 is 340 Kelvin. So now I can go ahead and do 88.89 liters. This side, 88.89 liters. Cancel, cancel. I take all these numbers, multiply, divide. I get 5.3384, but with sig figs, that turns to 5.3 atmospheres. And that's my answer. Last one on this page. We're taking a look at an unknown quantitative gas. Well, I have the pressure, so I'm going to put that in the spot where P goes. Remember, I'm always trying to put them in the same locations. I have the volume, 25 liters, equals the N. We don't know how many moles there are. We do know it's 0.0821 atmospheres, liters over mole Kelvin, times what is the temperature? Well, the temperature is going to be 300 point Kelvin. Okay, so I'm going to go ahead and take 0.0821 and 300 point Kelvin on this side. I'm trying to get rid of these. I want these to cancel on this side. And I'm going to put them over here, 0.0821 and 300. Cancel, 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 cancel. So the N is going to equal all this stuff. Now remember, I didn't put the units over here, but when I cancel everything out, I'm solving for moles. So I'm going to get an answer in moles, and I get 0.5057. With sig figs, it's 0.51 moles. And that's our final answer.